All right, so we're going to start with a module one, fundamentals of cloud computing, right? So let's get started. So this module is going to cover a lot of fundamental different terms. We're going to start with what is digital transformation, go inside what is cloud, talk about characteristics of cloud computing, service models, deployment models, and some general terminology to understand cloud better. So let's get started. Digital transformation. Let me read this for you all. Digital transformation uses modern digital technologies, including all types of public, private, and hybrid cloud platforms to create, modify business processes, cultures, and customer experiences to meet changing business and market dynamics. So, digital transformation in nutshell is, I could say, modernization of business, and this modernization is in level field with the changing market dynamics. So the business is going to adapt to what right now market is looking for, right? So you are going to be at the edge of the technology. This is what is, basically the idea behind digital transformation. Now, a good idea to understand this is looking at how it is happening in the world. And if you are in India, you might be already using UPI payments to make the payments on daily basis, right? So that's a way payment has been transformed, and it's a payment system has been digitalized for us, making it very very convenient, right, to make payments. So this is a transformation which we have seen in the payments, right? And the transformation, which I can think of right now is uh, the FASTag for toll payments, right? So before FASTag, we had to make payments in cash at the toll booth, and it would take time. The FASTags at stickers put up on the cars, make the payments for us, and that makes movement on the road much more comfortable, right? So that's another digital transformation which we have seen. So whole idea behind this is to make things faster, make things better, makes things quicker for us, leveraging on modern technology, leveraging on data for information, leveraging on this tooling to serve customers better and faster. Right, so that's all about digital transformation. At the end, digitalization is all about solving customer problems, right? Going to market faster, serving customers better, and also improving our efficiency, getting things done, and making profits out of the whole exercise of it. So that's the idea behind digital transformation, and generally, why we talk about digital transformation at the very beginning of this course is most of the businesses today are evolving, and digital transformation is, enabling businesses to move to the world faster, and cloud computing is playing a critical role in getting this done today. So we'll understand more about cloud computing ahead. What is cloud computing? Cloud computing is a delivery of computing services, including servers, storage, databases, networking, software, and analytics over the internet to offer faster innovation, flexible resources, and economics of scale. Businesses no longer need to maintain expensive on-premise hardware as cloud provider handles infrastructure management, updates, and security. So this, has evolutionized technology, big time, and the way we see technology today has changed after cloud computing. So we're going to understand some benefits of cloud computing. We're going to discuss a little more, but to break this definition down, what is cloud computing? Uh, Generally, for any kind of application to be served, right, we need servers, we need storage, we need networking over there. When all these services, right, are delivered to us by a cloud provider, we are not investing upfront into it, right? So unlike traditionally where organizations used to build their own data centers or run their own servers in a shared premise with others, uh, uh, and maintain them, manage them, to consume and serve their own customers. This can all be now, done via cloud computing without making a, you know, large expenses inside acquiring these resources. We'll understand a little more about cloud computing as we move forward. You can understand cloud computing better by looking at its characteristics. Very first thing is on-demand services. So whenever we do cloud computing, right, what a request, right, we can get the resources. So it's already there, available. It's up to us to provision it and use it. That's how it is on demand. Next key important consideration is the scale at which it allows us to work. So today, if I want to expand my, resource requirement from one virtual machine of maybe 8 GB RAM to 100 virtual machines of same size, right? A cloud provider should be able to handle the scale and give us the resources. The scalability is also something which a cloud provider manages for us. No, it's not just scalability, even elasticity. Not just that I can grow from 1 VM to 100 VMs, but if I shrink back after 2 hours from 100 VMs to 20 VMs or 10 VMs, right, a cloud provider should be okay with it. Unlike, a fixed model at on-premise where you get resources, right, and then, irrespective of use or not, right, you're still paying for those. Here, elasticity helps you, get benefit from cloud by getting resources only when you need it. So every time you have a surge of traffic, right, you can expand, and when the traffic goes down, you can reduce the number of running resources. That's all about elasticity. Now, you also have pay-as-you-go model in this. So you only pay for resources you consume, and that's how the billing works. So this is typically like an electricity connection at home. The more you run your electricity, the more you pay for it, right? That's how the pay-as-you-go model works. But this is if you compare this to on-premise, where you are upfront investing into a lot of hardware to get your own infrastructure in place. So if you compare that to electricity, you might be buying a generator, putting in diesel inside it, and then running it to get that electricity. So generally, it becomes cheaper when you get it from a electricity provider, right? For that. Now, other thing is that all these resources are always available over the internet. You don't need to, go anywhere for provisioning or consuming the resource. You can always connect to the infrastructure over the internet. Now, besides that, it is a robust infrastructure. It is highly available and reliable. So, unlike when you do things on premise, you have to think how you're going to get a disaster recovery in case your primary site fails. How you're going to handle if your power fails. So this all effort and strategy around it is taken care by the right provider. It is by design highly available and highly reliable in terms of the service, and it is backed by the service level agreement. So what is the benefit of going to cloud, right? So first thing is it is efficient, cost efficient in terms of physical infrastructure. If you buy hardware, you need teams to manage that infrastructure, and then pay for all the cooling and internet and power and teams to handle the infrastructure. It is much more efficient to do it when you do it in the cloud in terms of cost. Now, cloud provider also benefits from economics of scales. So what happens is whenever you manufacture something in a very large quantity, okay, you are able to cut down and trim your cost drastically. Some of these cloud providers manufacture their fiber cable, their own hardware, so they can make things much more competitive in terms of what you can get from a commodity market. So they are getting benefit of large economics of scale. Some of these benefits are passed on to the customers, making it much more cheaper for us to operate in the cloud. Democratization of technology. Now, generally, what happens is if you try to use latest technology, right, you need to find good, team to handle this, to learn and adapt to that technology. It becomes very easy to do it in the cloud because it is delivered as either as a serverless format or a managed service to you. So you're just consuming it. You don't get inside the hood of designing and solutioning and actually provisioning that kind of a service. So A lot of such things happen when you go to cloud. In today's world, you have generative AI as a big buzz, and most of the cloud providers have that component available today in the cloud as generative AI. You can use that to uh, build images, text, videos, audios in the cloud directly. So that is what is democratization of technology that is being offered to you today. Regulatory and compliance. Now, generally, what happens? You have to law of the land, right? You have to go through the compliance. You have to go through the audits. Now, when you do it in cloud, your life is much more easier because a lot of audits and compliance is already taken care by the cloud provider. So when you select a particular service to use, right, if the service is compliant, generally that compliance is directly forwarded to your application also, that your infrastructure is compliant, and you can now move forward in using it. So it reduces the effort in getting the compliance and in place. Now, lastly, security and data protection. Now, of course, security is utmost important for everyone, be it cloud, be it on-premise, anywhere you implement it is, nobody ignores this. But when you go to a large cloud provider, right, they have much better security practices, much better security budgets. That's the main thing, is because the scale and the size they deal with, right, and the number of customers they serve. Uh, of course, it is the utmost importance for them also to secure the environment, and they do it in the best possible way. In turn, we also get benefit of the effort and security which they take, right? Because their environment is secured. We don't need to look at the infrastructure security as such. Of course, applications which we build on it, we get the required tools for making security for those, and we need to deploy and use those tools correctly. That's something on us to make sure that when we consume cloud, we are securing things in the right way. At the other end, cloud provider takes care of his part of security. This is generally referred as a shared security model. So service models, right? So let's start understanding what is infrastructure as a service. Now, infrastructure as a service is when we get pure computing capability, storage capability from the infrastructure provider. So we can start a virtual machine, we have storage attached to it, and we can install, configure, and use it the way we need. And this is what we call as infrastructure as a service, IaaS. So here billing is based out of the amount of time we run resources. So if the server is on for a day, we pay for that day. The day, or we run it for an hour, we pay for the hour. So depending upon the amount of time we consume, we pay for it. But the entire infrastructure is given to us as a service over the internet. That's infrastructure as a service. Next, what we see is platform as a service. Now, platform as a service is generally when they create more value for us on top of the infrastructure and give it to you. So, that's why this architecture is trying to show you this, that, this is the core of everything. Infrastructure is always there. Just that when we do platform, we don't see the infrastructure. Platform will take care of the infrastructure for us. What do I mean by that? So there's a service in GCP called App Engine. We'll talk about this in length when we go to Compute Engine. But what this does is we just upload the code to the App Engine. Underlining all the infrastructure is taken care by it. So as a developer, you just need to write the code. That's it. That's what is required for it. So that's a platform service. We have other services like, for example, Cloud SQL. So it's a SQL database service that we have. We don't have to do installation, configuration to use that database. We just start the server in Cloud SQL and we connect to it and we start using the database directly. So that becomes a platform for us. So on top of infrastructure, value creation is done for us and it is given to us to consume it. That's how the platform services work. Infrastructure as a service, core infrastructure, platform, value creation on top of infrastructure and then given to us. Software as a service is when you just subscribe for some services and use it. Like a good example of this is Office 365, right? So in Office 365, we get email, we get hosted documents and Excel sheet and everything, right? So here what happens is that we are not paying for any kind of infrastructure, we are not doing any kind of platform, we are just consuming the service. Right? So software as a service is enables us to quickly access without any installation, configuration. Generally, very minimalistic effort is required in consuming it. We pay per user per year generally as a part of the licensing fee that we occur to it. Now, in terms of recommendations, right, whether you should go with software, platform, or infrastructure as a service. Generally speaking, you want to always see if software as a service is available, go and use that. If not, then go to platform as a service and see if you can use a platform and then build upon that. And now, if software and platform both are not available, then you go to infrastructure. So maybe when you're solutioning something, you want to see whether it's available in software as a service or not. If yes, then nothing like it. Otherwise, look at if platform can take care of some amount of effort for you, then use the platform, and then whatever you need, platform can't help you, go ahead do it with the infrastructure as a service. Right? That's how you should be generally approaching this. So next thing, we just wanted to show you this, that the effort pyramid. So I told you, why you should be preferring software over, platform over infra, right, in terms of implementation. So this is what, explains that why you are doing it. It's just that the effort pyramid, right? If you see what cloud provider, in when you do software as a service, right, you are just doing data and configuration of yours. So this is the only effort which you have to take. Now, this passes on. Let's look at platform as a service. When you do platform, you're doing data and configuration, you're doing your application load, and you're still setting up the scaling parameters, right, in the platform. So this is the effort when it comes to platform services. Now, same thing when you look at infrastructure over here, right? You're doing data, you're doing application code, you're scaling, you're putting up runtime, you're doing the OS patching, updates. So all this becomes your effort. Cloud provider's effort is just virtualization and hardware. And when you do this on-premise, everything becomes your effort. So this is GFC, give you an insight of how much effort you have to do moving from, on-premise versus software. Software becomes very, very simple for implementation. We have not spoken about function as a service yet, containers as a service yet, so we are not discussing this in this particular, slide. But yeah, for now, let's understand what software, platform, and infra as a service has to offer us. So different deployment models in cloud, on-premise, private cloud, public cloud, hybrid cloud, and multi-cloud. Let's talk about them one by one. So on-premise, organization has their own data center. They have complete control over hardware security, requires substantial investment inside it. Generally, this was the way, the whole world used to work at one point of time. So one way was to do it on-premise by yourself. The other way was, use co-location facility. Co-location facility is, a place where you can get space to put your own hardware. Okay, so what they do is they give you on rent space, and then you go and you set up the infrastructure over there. So large enterprises would do on-premise. Smaller companies, what would they do is they would go to colo facilities, rent space, whatever, 40, 50, 100 servers they need to put up over there. They would rent enough space for it and set it up over there. So this would, allow them also to, in a way, get a correct environment for their servers in terms of cooling, redundancy in hardware, and electricity, without doing a very large investment directly in by setting up their own data center, right? So that's a benefit between what you get. But this was the way of doing things at one point of time before cloud computing came in. Private cloud is a dedicated cloud resource for a single organization. It gives you enhanced control and customization, ideal for sensitivity data and regulatory compliance. Now, between on-premise and private cloud, the major difference is the way the setup has been done. Traditionally, when you say on-premise, it was mostly infrastructure as a service running on virtualized environment, and then whatever we wanted, we were building on top of it. Private cloud, when we look at it, it is little more, delivery is via, you could say, APIs a little more. You have, a bit of a solutioning designed in terms of storage, compute, and other key services, and then each service can individually expand as we need. So a little more modern way of implementing, things have happened with private cloud. Public cloud, I think we've spoken quite a bit about it. It is shared cloud resources over the internet, scalable, cost effective. Okay, and we have service providers like AWS, Google, Azure, Alibaba, Oracle. They are all public cloud providers. Hybrid cloud is a combination of public and private cloud. It is also when you have on-premise implementation and you have a public cloud implementation. We also, call that as a hybrid environment. Generally, certain data, certain applications are running in on-premise and certain are running in cloud, and that is where hybrid environment is established. Multi-cloud. So using multiple public cloud is very common today, and this increases the flexibility, reduces vendor lock-in, right? And so generally, what happens is in most very large enterprises, a particular team is deciding which cloud they should use for their particular problem statement. So for very large enterprises, this is common that they are consuming more than one cloud, and at times they are also connecting between these clouds for their services and solutions to work, right? So this is like a new normal today in the industry. Community cloud, shared cloud infrastructure for an organization with common needs. Generally, this is not very commonly seen in the industry, but government agencies, educational institutions. So these are, generally private clouds, but built for multiple similar organizational needs. So you may have, certain set of government agencies, they need a cloud, so they may combine their resources and build one cloud and share the resources with them internally among themselves. So they might use a private cloud which they themselves get it built, or they themselves build it, and then they are consuming it, and they are so the cost of compliance, cost of maintenance and updates, right, is distributed across the agencies. So that's where you would see a bit of community cloud. Not very popular, but it still exists, right? It's there. Some more terminology with respect to cloud computing. Greenfield projects and brownfield projects. Right? So greenfield is when you start completely in the cloud. Generally, if you are a startup company, then this is the best thing to do, is start in the cloud, because your upfront investment is not there in terms of buying any hardware and getting resources in place. Brownfield projects are when you have already the infrastructure, okay, and then you are going to now leverage on cloud, and you are now going to modernize certain amount of applications to be used on cloud. So that is where you have existing infrastructure, you build compatible infrastructure in cloud, and then you work together with both of them. Generally complex, uh, but then that's your journey basically, to start from on-premise to eventually move to cloud. And this is generally referred as brownfield environment, where you have existing legacy and you are doing modern in cloud, and they are both working together, right? It's a complex situation, but it's a journey which sometimes organizations have to go through when they adapt to the cloud. Multi-tenancy is simply when multiple users or groups of users share the same infrastructure, right? So a simple example is renting a house in a large building, right? You are just renting one house in a large building. Building resources are shared with everyone. Everyone uses the lift, the water supply, the drainage systems, right? Cleaning services for the building. But we stay in our own house, right? So we have our own door, we have our own security, we have our own privacy inside it. Same way here, we are keeping our data in the cloud. It is separate, it is isolated, it has security, it has backed with privacy policy, it is backed with compliance, and others are also using the same way. In turn, everyone benefits from the cost reduction, because since multiple users are using the same environment, same infrastructure, cost can be distributed, reducing effectively the cost per head. Right? So that's how the multi-tenancy works. Replication. Now, replication is a very common term in the industry, and I want to highlight this over here. When we copy data at multiple locations, right, we call it replication. This improves the durability and availability both. So if the same data is copied at two places or three places, if one place is having an outage, I can retrieve it from the other place. So it's so simplest example today of this could be your Google Drive or OneDrive. So if you configure Google Drive in multiple laptops, it will sync the data between the laptops, and you can access it from any of your laptops, right? So it's a example of data being replicated from your two laptops and the cloud together with it. So that's the simplest example which I can think of. Some more terms: automation and orchestration. So what is automation? Automation is basically when we get some task done without human intervention or with minimum human intervention. It involves creating scripts, tools, deploying application and configurations in a way that automatically things happen, generally done to save time and effort for recurring items, right? It's something which you have to do again and again. Good idea would be to do an automation around it so that your effort is reduced. Now, orchestration generally goes a step ahead from automation, and in that, generally, you have multiple automated tasks and processes which need to be, triggered and managed sequentially in certain flow. And it's a larger, it's a bigger layer, and it's a layer on top of generally multiple automation tasks that we need to do involving integration with multiple services, and it ensures that different automated tasks are executed effectively and efficiently. That is generally the orchestration is refers to. Now, again, these are very common terms, but I thought it would be good we cover over here. Bandwidth. What is bandwidth? Bandwidth refers to data transfer rate of a network. Right? So, higher the bandwidth, the more data can flow simultaneously. Latency, a very common term today in the industry. It is the amount of time which data packets take to travel from source to destination. That is called as latency. Lower the latency, the better is the performance. For real-time applications like gaming and video calls, this is very, very critical to be low. Bandwidth and latency both overall affect our network performance. ISPs. Internet service providers in India would be your Bharti Airtel, Tata Communications, you have Reliance Jio, Hathway, and many more. Right? So they all provide internet connection from which we can connect all your telecom services, Vodafone, Airtel, your Reliance Jio, BSNL, they all are also ISPs, they also provide internet connections to us. Now, to understand about IP address and DNS, let's shift to whiteboard. So we are going to cover about IP addresses now. IP addresses, of course, everyone understands, they are required for communication between, your computers, your laptops, mobile phones, right? So all of them require an IP address for communication. So our traffic, right, doesn't go on direct addresses. So, if you wonder, right, when you type some website, www. whatever website you want to go to .com or .in, it actually, DNS at the back resolves it back to an IP address, and actual traffic flows on the IPs, not on the names. So that's the use of IP addresses. Now, IP addresses are bifurcated primarily into two types. One is a private or an internal IP addresses, and other one is your public and external IP addresses. So this over here is a sample set of your public IP addresses or external IP addresses. So there are a lot more in this. I have just copied a few of it and pasted from internet just to show it as an example. Whereas in private, right, this is what we have in my RP version 4 IP addresses. This is it. This is what is available. Now, the major difference between the two, your internet works on public IP addresses, okay, and private IP addresses can work inside the organization. So if you're sitting in your office and and there are hundreds of people sitting around you and working, right? It's not that everyone does have a public IP address. They all use private IP addresses, and only at the edge device where your internet connection happens, right, the request goes out using a public IP address. We'll talk about this little later also, but right now I just want to introduce what is a public and private address. Next, you will understand what is subnetting. Now, you would come across IP addresses, noted in this way, a number with a slash in front of it, like 10.0.0.0/16. Look at the first part on the top line, right? Representing a block of IP addresses. Slash 16 over here is referred as a CIDR block. Now, we generally group IPs into small sections to make it more usable, and that is called as subnetting. Now, IP version 4 is a 32-bit IP, and each octet of it has 8 bits. So 8 plus 8 plus 8 plus 8 is equal to 32. Now, when we say slash 16, right, that typically what it means is that we are going to lock the first two octets, okay, and not use them at all, okay, for giving it to any of the host, that is any of the machines, for example, any IPs. When I say it could be given to a server, a desktop, a laptop, any device, right? So we are not going to give them. We are going to only use the part that is open, that is last two octets of it. So this is decided by the CIDR block which we place. Now, when I place this CIDR block of slash 16, how many IPs do I get? Right? So IPs start from 0, okay, and end at 255. In all, giving us 256 IPs. This is the range of IPs. So when I say I have slash 16 IPs, I can start giving IPs to any devices with 10.0.0.0 as my first IP. Next would be 10.0.0.1, 10.0.0.2, so on and so forth. I can keep going on to 10.0.0.255. Now my first octet gets over with it because the IPs are going to be from 0 to 255, right? So this gets over here. I have exhausted this limit. So I have second octet. Since it is slash 16, this octet is also available. So I'm going to do 10.0. Now 1.0. So next octet I will open, and I will keep doing this till I reach 10.1.255, the last IP in that octet. And once I've exhausted this IP, block also, I'll move to the next, then move to the next, move to the next, keep going on. Finally, at the end, I will reach to 10.0.255.0. And this is my last octet, and the last octet will start from 10.255.0 and will end with 255.255. This will be the last possible IP in the entire sequence. So this will give me how many IPs, right? To calculate this, I could simply do a math that it's combination of 256 times 256, that is giving me 65,536 IPs. Right? So these are the total IPs which I can get from slash 16. Now, why do we do this, right? We want to reuse this IP much effectively. Okay, so what we do is we split them into smaller blocks and make it usable. I'll give you an example how this happens and why this is done. All right, I have an example over here. Now, this example I've taken up to explain what is subnetting and why do we do it. Let's say we have this building which is of 6 floors, okay, and it requires to have network installation for CCTV camera, Wi-Fi and LAN. So 3 different networks are what we are trying to run over here. Now option A, right, which I have is I can take 10.0.0.0/16. I'll get 65,000 IPs. I need maybe less than 10% of the IPs, and I can have all the devices inside that building get IP from this range. That's one way I would say you can think of doing it. Other way of doing it is I split these IP into smaller blocks of IPs, okay, and I'm splitting it with slash 24. So when I do slash 24, right, here if you see 10.0.0.0, this will get locked. I will have only one octet remaining, and IPs are from 0 to 255, so 256 IP I will get it over here. That's how I'm going to isolate them. So if I do it this way, I can segregate one block 10.0.1.0 for first floor CCTV, then second, third, fourth, and then start with LAN and then eventually Wi-Fi. Now here what I'm doing is I'm still using the same IPs, but I'm carving it into smaller block of IPs, making it more reusable. It consumes less IPs in implementation, also allows me to put up network policy and security around each network separately. So the port required by CCTV camera may not be required by LAN. So I can control which device will have which port open on which network. So I get better control over my network. I can troubleshoot things more easily, and this becomes much more effective in network communication also. So generally speaking, I would always follow option B. Rather to disclose this, right, they don't work in isolation. We have option A, that is we decide that this is going to be the larger block of IPs and I'm going to carve smaller block from it and create small networks out of the larger block of IPs which I have selected. This typically is referred as subnetting. Devices in one network cannot talk to other network directly. So devices in first subnet, which is of CCTV, cannot talk to devices in second subnet until unless you do routing between them. So by default, each subnet is going to be an isolated environment. I just wanted to cover this basic concepts on IPs and subnets over here. Understanding the costing part of things, right? So what is OPEX and what is CAPEX? So OPEX is operational expenditure. This is an ongoing expenses which you do to run your day-to-day business. So in case of IT infrastructure, you will be paying for power, cooling, maintenance, IT teams. This will all be your operational expense when you run infrastructure by yourself. CapEx refers to capital expenditure, generally the upfront money which you invest, right, for building your data center and setting up the infrastructure over there, server, storage, networking. All these investments is, going to reap off benefits over a period of a long time. That is what is the CapEx. So now let's try to compare between cloud and on-premise, how the OPEX and CapEx model differ over here. So your cloud computing is going to be pay-as-you model. You are paying for resources which you're consuming. So you have a higher OPEX cost over here, and it is a subscription-based cost which is levied. Versus on-premise where you're doing a very high upfront CapEx. It's a huge investment into building hardware, software. Uh, that's all your upfront capital expense which you have to incur into it. Now, flexibility wise, cloud is very flexible. Resources can be scaled up, down as and when you need. Now, on-premise, the flexibility is low. In case you need more infrastructure, then you need to buy more hardware, set it up. You can't scale down easily because the infrastructure is going to lie down, unused if you're not using it, if you're scaling down. So that flexibility is not there when it comes to on-premise. Now, risk and financial commitment, your risk is low. It's pay-as-you-go model, so you're not committing into anything. You can always, terminate the resources and stop your billing if things don't really work as you have thought. Your risk is very high, regardless of actual usage. You are made the upfront expense inside it. Your infrastructure is up and running always, kind of with it. Maintenance upgrades, cloud provider takes care of most of the infrastructure cost which they have done. They take care of the primary infra for you. So your end is just to take care of your applications that are going to run on it. So your effort is very, very minimalistic as compared to, in on-premise, your IT team will be required for maintaining upgrade, security, all that is going to come on the internal IT team. Depreciation, here you are not writing off with time in terms of your books because it's a rented service. You can keep renting it. You're not going to write off anything from there. Whereas hardware depreciates over a period of time, so you have to reduce its book value and replace the hardware over a period of time. So that's an ongoing effort, and recapitalization happens over years. You're investing one more time to make the environment usable. Security and compliance. So cloud provider builds infrastructure-based security for you. It gives you tools and other services to secure whatever you are deploying on it. This is a shared security model. Versus full security effort is required, from the on-premise team. So right from, security of the building in which the hardware sits, security of, the patching, updates, vulnerability checks, everything is on the on-premise security team in case of an on-premise implementation. Right. So generally speaking, your capex, right, is much higher in on-premise implementation, and your opex may be a little lower as compared to cloud because of the upfront, all the upfront investment inside it, right? Your recurring cost may be a little lower than what you are spending on cloud, but this comes with an upfront massive investment. So now what we're trying to understand is what is the total overall cost of ownership. Now when we evaluate, right, we evaluate not based on the capex and opex only, but we talk about what is the overall cost of ownership. Now when it comes to cloud, right, your short-term cost is, since there's no investment, that it's very low. You're just spinning up things and renting it and using it. Long term, it may be expensive because things are always on. As and when business expands, the resource requirement keep growing, right? So that in terms, it becomes an overall ongoing cost till then the infrastructure is running. Now you can tune it by dynamically scaling and selecting the right pricing plans, right? So that can help you optimize the cost. Versus in on-premise, you are doing a huge upfront cost inside it, and you're going to write that out of a period of time. Comparatively, recurring cost is less if you compare that to an ongoing cost from cloud because of the upfront cost you've already done and you own the resources now. So you're not renting anything, but you're consuming, and for that consumption, you have certain amount of fixed monthly ops cost also which you have to bear, but that will be generally less than what you're paying in the cloud if you compare the same amount of infrastructure. Right? For a large enterprise, also with time, it has proven that overall cost of ownership reduces in the cloud, and that is why you see, most of the large enterprises leveraging on cloud big time. So this module we covered a bit around digital transformation. We discussed a bit around cloud computing. We looked at the different service and deployment models of it. We touched upon quite a few terminologies over here, and then we covered how capex and opex are different from each other. Now let's get inside Q&A section. Question 1. An organization decides to migrate their on-premise environment to the cloud. They need to determine which resources, components they still need to be assigned ownership. Which two functions does public cloud provider own? Okay, so from the list of below responsibilities, what are the ownership that will be taken care by the cloud provider? That's what it's trying to ask you in the question. So option A, hardware maintenance. Option B, infrastructure architecture. Option C, infrastructure deployment automation. Option D, hardware capacity management. Option E, fixing application security issues. I think it's very straightforward and simple. Hardware maintenance and hardware capacity is something which we absolutely have no access or no control over, and that is something which cloud provider takes care. Next question. Each of three cloud service models, infrastructure as a service, platform as a service, and software as a service, offer benefits between flexibility and levels of management by the cloud provider and the customer. Why would SaaS be a right choice of service model? So basically the question is trying to ask you is why would SaaS be the right choice? So whatever in the options make SaaS as a right model to select, you have to pick that up. Option A, you want to balance between flexibility of the customer and level of management by the cloud provider. Okay. Option B, you want to minimize the level of management by the customer. Option C, you want to maximize the flexibility of the customer. Option D, you want to be able to shift emphasis between flexibility and management by the cloud provider as business need change. Okay. So when you do software as a service, right, you absolutely have very limited effort to be put. So your involvement in terms of management is minimalistic. Okay. So I think that is what option B is talking about. You want to minimize the level of management by the customer. Now, wherever you have, the flexibility, your effort of management also increases. So, anywhere where you are trying to balance flexibility, you will get the ownership, you will get the control, and you will get the effort with it. So, you will move from PaaS to platform and to infra as you move from the effort pyramid, you know, least being with SaaS provider and maximum being with the infrastructure as a service, IaaS. Right? So, that's how it differentiates. All right. So, question 3. Your company has recently acquired 3 growing startups in 3 different countries. You want to reduce overhead in infrastructure management and keep your cost low without sacrificing security and quality of services to your customer. How should you meet these requirements? Option A, host your subsidiary services on-premise together with your existing services. Host all your subsidiaries services together with your existing services on a public cloud. Build homogeneous infrastructure at each subsidiary and invest into training their engineers. Build a homogeneous infrastructure at each subsidiary and invest into hiring more engineers. So I've read all the 4 options. Okay. So you are building new infrastructure for all 3 of them. Right from the first option, you are doing it on premise in your own environment. Uh, B, C, and D are also doing the same thing. C says that build a homogeneous infrastructure for each subsidy. That is, you build data center for each subsidiary separately, and one says train the engineers, and option D says hire more engineers. Right? So the right answer is host everything you know uh, in public cloud. So your option B. Right? Now, why? Because you want to keep your cost low. Okay, if you read the question right, you want to reduce the overhead of infrastructure management and keep your cost low without sacrificing security quality of your services to your customer. So if you don't want to do the upfront costing, then you'll have to go inside the public cloud, right? That's the best way out. All right. Question 4. How should a multinational organization that is migrated to cloud consider security and privacy regulations to ensure that their compliance is with global standards? Option A, comply with data security and privacy regulation for each geographical region. Option B, comply with regional standards of data security and privacy because they supersede all international regulations. Option C, comply with international standards for data security and privacy because they supersede all regional compliances. Option D, comply with regional data security regulations because they are more complex than privacy standards. Now, let's start with evaluation of D. Comply with the regional standards because they are more complex. Now, complexity is there in every compliance. Okay, so you can't compare apple with orange. So that's absurd, right? I cannot say compliance over here is more complex than compliance over there. Compliance is compliance, and it's complex everywhere. Now, option C says comply with international standards for data security and privacy because they supersede all regional regulations. So, see, it's law of the land, right? The land changes, the law changes. So, there is no one universal law that works everywhere. I cannot say that, okay, I am complying with this is international, and be it the country, this law should work. So, it's not that way. Every country, every region has their own compliance standards, and you have to comply with those. So that's how the complexity is. So that's actually an incorrect statement. Option B, comply with regional standards of security because they supersede all international standards. Again, this is vague because I cannot say if I have if I'm in Europe and I have GDPR, that means US HIPAA is already taken care of it. So it doesn't work that way, right? The region you are, you'll have to comply with those standards. So you're only left with one option: comply with data security and privacy regulations for each geographical region. Every region where you are running your infrastructure and you're serving your customers in that local geographic region, you will have to comply over there, right? And that's the only way out. So your option is option A. Question 5. What would provide near unlimited availability of computing resources without requiring your organization to produce and provision new equipment? Option A, public cloud. Option B, containers. Option C, private cloud. Option D, microservices. I know we have not covered it, containers and microservices, but yes, unlimited compute resources is what a public cloud can surely offer you. Your organization has decided to modernize the application in the cloud to keep up with their customer needs. What may have prompted this business decision? So basically, why they have decided to move to the cloud. Their on-premise applications can only auto scale to meet the demand. Option B, they want to change from pay-as-you-go model to capital expenditure model. Option C, their source code change erroneously without developer interaction. Option D, their on-premise application take months to update and deploy. Okay. So it's very straightforward. Your option D is the right answer, that your application takes months to update and deploy. The option A is the other way. It says that on-premise can auto-scale to meet the demand. So if it could happen, then why they would go to cloud, kind of. This is something which generally your cloud services offer you. And again, option B is again the opposite. You want to move to pay-as-you-go. You want to change from pay-as-you-go model to capital expenditure model. So your on-premise is never pay-as-you-go. It is always capital expenditure, right? Pay-as-you-go is in the cloud. So the option itself is mentioned incorrectly. And option C, their source code changes erroneously. This is an operational issue, right? How can the source code change without developer interaction? So this is a process-related problem. Can happen even in cloud. It can happen everywhere. So this doesn't change if the process doesn't change, right? How you do the application updates. Right? So your right answer is option D. And generally this happens any on-premise setup, right? When you want to expand that, there's a long process, right, from approvals to selecting the hardware, floating the quotations, getting the hardware, testing the hardware, and then deploying it. Normally it anyway takes from maybe a couple of weeks time to a couple of months time also it would take. Question 7. Why do organizations often struggle to scale their on-premise application infrastructure? Option A, scaling compute instance could breach compliance and or regulations. Option B, increased compute capacity is time consuming and costly. Option C, their serverless compute functions struggle to meet the demand. Option D, multi-cloud architecture is complex and expensive. So the question says that why do organizations struggle to scale on-premise applications? So what is the challenge when you want to scale at on-premise? So your option, B is the right option. Increased compute capacity is time-consuming and costly when you do it on-premise. Now, rest of the three, if you evaluate, right, scaling compute instance could breach compliance. That is not the fact, right? So scaling doesn't breach any kind of compliance. Serverless is generally implemented in cloud itself, and multi-cloud architecture itself talks about multiple clouds being used together. So, well, the question is why the organization struggles to scale on-premise infrastructure. So, option C, option D are more related with the cloud components, and so option D is your correct answer. Question 8. A multinational organization has decided to use public cloud service to modernize their infrastructure. What is the one benefit of doing this? A. They can perform hardware maintenance outside normal business hours. B. They can expect 100% service availability in all the regions. C. Built-in security is no longer required during data migration. D. Access of data and compute resources is not tied to a geographic location. Okay. So, what is the benefit of going to cloud, right? So, you don't have to do hardware maintenance. So, option A is not relevant. 100% SLA is not there. So, SLA is varies from service to service, and it's not at 100% for all the services. So that also is not the right option. Built-in security is no longer required during data migration. Security is a must everywhere, even with cloud, right? There's a shared responsibility model where some amount of responsibility is going to be there on the customers to configure things correctly and use. We'll talk about that later also in the module, but that's also not the right option. So option D is correct. You can access data and compute resources over the internet, so you're not bound to any geographic location for accessing the resources. Right. So question 9, your organization wants to upskill the IT staff. How can they do this in a transformational way? Prioritize training current employees instead of hiring new recruits with cloud expertise. Option B, prioritize giving privileged access to third-party partners and contractors to fill the IT knowledge gaps. Option C, create a culture of self-motivated, isolated learning with official training material. Option D, create a culture of continuous peer-to-peer learning with an official training material. So, out of 4, right, 3 options are all about, training. And option A doesn't say how to train, but says that you should train instead of recruit. Option B says that you get contractors and third-party, people to help out. There is a knowledge gap. So B is basically more than training. It's about hiring vendors or contractors to help. So if you want to train, right, then what are your options? So option C and D both are, talking about training. Option C says that do it self-motivated in an isolated learning format. Option D says that do continuous peer-to-peer learning with official training material. So one thing which, if you're new to, these exams, right, what I feel is a good indicator in this question is the official training material. That itself says that probably either of them should be the right options. Now, learning in isolation is or learning from peers, right? Peer-to-peer learning can be much faster, much more effective. So your right option is option D: create a culture for peer-to-peer learning. Right? So this is your right option. Question 10. An organization wants to digitalize and share large volumes of historical text and images. Why is public cloud better option than on-premise? So question is saying that why is public cloud better? Okay, in-house hardware management, that's not public cloud, that's private cloud or your on-premise. Okay, option B provides physical encryption keys. No. Again, physical keys for encryption. So, okay, let's look at option C. Cost effective at scale. Yes, cloud providers are able to, compete very nicely with on-premise because of the scale they deal with, economics of scale. Option D optimizes capital expenditure. So when you do public cloud, there is no capital expenditure. So that is irrelevant. Okay, so the right option over here is option C, cost effective at scale, right? So why is public cloud better? Because, it is able to give you better cost effectivity at, when it comes to pricing. All right. Uh, Thank you so much for watching Module 1. If you have still not subscribed, please do that. That helps me and motivates me to make such videos. Do like and share with your friends. Put in any comments how you like the videos. If you have any doubts, any questions, feel free to ask those as well. I will do my best to reply you as soon as possible. Once again, thank you so much.